Today, we will be looking at the respiratory system. The first question we'll answer is, what does the respiratory system do? The functions of the respiratory system are to obtain oxygen and remove carbon dioxide, filter and trap incoming particles, control the temperature and water content of incoming air, and produce vocal sounds, as well as help regulate blood pH. Let's take a look at the structures of the respiratory system. The larynx contains the vocal cords, which vibrate to create sound. The trachea, or windpipe, extends downwards in front of the esophagus and into the thoracic cavity, where it splits into the right and left bronchi. The bronchus, bronchi, and bronchioles make up the bronchial tree. At the end of the bronchioles are alveolar sacs, or clusters of small air sacs called alveoli. Let's take a closer look at the alveoli. This structure is the site of gas exchange. Gases move by diffusion, and each gas has its own partial pressure. Here are the factors that affect gas diffusion: surface area, distance across membranes, and change in partial pressure. These are all caused by diseases. There are two gases that are transported: oxygen and carbon dioxide. In oxygen transport, oxygen combines with iron in hemoglobin to form oxyhemoglobin. If not enough oxygen is being taken in, then hypoxia and cyanosis will occur. In carbon dioxide transport, there are three methods: dissolved into plasma, form carbamyohemoglobin, and form as a bicarbonate ion. Now let's talk about breathing physiology. The factors that affect breathing are chemical changes like those that affect pH, inflation reflex from the stretching of lung tissues, emotion that causes hyperventilation, surfactant amounts, and airway resistance. Now we'll look at the respiratory system's regulations and control. The medulla sets the rhythm and the pons moderates pace. So, what could go wrong? Apnea, SIDS, cystic fibrosis, asthma, bronchitis, emphysema, lung cancer, HAPE, COPD, sinusitis, bacterial or viral infections. Now we'll talk about breathing mechanisms. Air flows in and out of the lungs due to a pressure gradient between atmospheric pressure and the pressure inside the lungs. Air moves from high to low pressure. Normal and quiet exhalation is elastic recoil of tissues. Forceful exhalation uses internal intercostal muscles and abdominal muscles. Normal inspiration is due to a pressure difference when the thoracic cavity increases from diaphragm muscle contractions, as you can see in this diagram. Let's take a look at lung capacities. Tidal volume is normal breathing at rest. Vital capacity is maximum exhalation after maximum inhalation. Residual volume is air that never leaves the lungs and keeps the alveoli open. What attributes to a larger lung capacity? Height, age, health, gender, environment, habits, hobbies, and if you are an athlete. Now, view this diagram for a moment and see what you can remember about the respiratory system off the top of your head. Now let's review. The structures of the respiratory system include the nasal cavity, larynx, pharynx, trachea, lungs, bronchial tree, and diaphragm. At the end of the bronchioles are the alveoli, the location of gas exchange. Oxygen and carbon dioxide are transported through the lungs. Hopefully you could take something useful away from this video, and thank you for watching.